KD, and I really appreciate this invitation and the opportunity to share some of this exciting content with you.
Thank you. Thanks a lot.
We have a lot to talk about, so let's just dive right into it. I'm going to give a brief overview of high availability disaster recovery, but the assumption is you'll know a little bit about availability groups already. You don't have to be a rocket scientist to know to see the differences. Well, let me dive into the agenda first. We're going to do an overview. We're going to talk about some of the exciting new features. I'm not going to read these off to you because we will dive into them, but they're pretty exciting. And the thing I'm most excited about is the performance, and that may not surprise you. For those of you who know me, I'm a perf guy. I specialize in flipping the faster bit. And the exciting thing about SQL Server 2016 are the incredible improvements in performance in the network transport layer. And be clear, the results that you're seeing here, you do not have to be a rocket scientist. We'll dive into them later. You do not have to be a rocket scientist to see a profound difference between SQL 2014 and 2016. And be clear, the only difference here when these tests were done, they were done on the same hardware. This was simply a function of upgrading from 2014 to 2016. Pretty cool stuff. But there's a lot more than performance that availability groups were enhanced in 2016. So let's talk about those. First, a review. I'm getting a little bit of a delay getting the slide. There we go. Oh, I'm glad the slide came up. If you want a full copy of this deck, feel free to contact me directly, and I'll send a copy to KD, of course, that he can provide. But feel free to contact me directly for a full copy of the deck, as well as with any questions you may have. If you navigate the deck, take advantage of PowerPoint Sections feature. It's a feature that's very little known and underutilized, very simple to use. When you see the navigation pane on the left, simply collapse everything, and you'll end up seeing what's on the right. Basically a table of contents built into PowerPoint. And it's very, as you see from my guidance here, very easy to implement. You can skip directly to the section that you choose to. Again, just ping me if you'd like a copy of the deck. Oh, not again. KD, you got a help desk over there? Okay, guys.
Repeat that, yeah.
By now, just kidding, guys. Even after only a few seconds, many of you have probably figured out that this is just a screen scrape, or I would have been disconnected. You wouldn't be able to see this. But surely you've seen one of these, right? Microsoft collects these in the Watson database. It's an awesome architecture shepherded by a friend of mine. But the point is, do you have a plan? Do you guys have a plan to recover from something like this, or worse, for all of your enterprise production servers? Some of you may, some of you may not. Even if you have you tested it? You wouldn't believe the number of enterprises that we visit. As a consultant for MCS, I have a mentee who's a premier field engineer who some of the challenges. And those of you, I know Kimberly Tripp presented recently. I have been to her and Kim's SQL Skills HADR classes among their other immersion classes, and they are constantly sharing stories with us of enterprises who don't have a robust HADR strategy. So let's talk about that for just a minute. What is your plan? This is something I saw just a few years ago by my former teammate. Some of you may know Sanjay Mishra of SQL Cat. I mentioned I've attended the SQL Skills Immersion event, and the attendees there were from companies mostly foresightful enough to send them to such world-class training as Paul and Kim's, and most of these companies, most of these engineers, architects, had a pretty good HADR plan in place. However, I've heard of so many war stories. Yeah, believe me, HADR strategies, not much better than this, are out there. They're everywhere, in fact. Don't be this guy. HA is the ability of a system to service an application or service. Disaster recovery is the plan to return to normal operations after a catastrophe. And you have to take into consideration concepts like recovery point objective, recovery time objective. That's not something we're going to dive into today specifically, but those are concepts you need to be aware of. And again, we're not going to dive into this as well. This is an overview. The important point from this slide is it's very important to get the business continuity right. Anything at the intersection of people, processes, and technology can be complex. HADR has many components. The technical part is the easy part. And a real robust strategy may not be easy to implement, so be prepared. And why are we talking about something as straightforward and fundamental as backup? Well, this is backup, the most fundamental aspect of your HADR strategy. Stop me if you've heard Kimberly Tripp's. By the way, Kimberly's one of my heroes in the community. She was an informal mentee to me many years ago. She didn't know it, like you guys. I attended many of her webinars and learned a lot of what I know thanks to her. So stop me if you've heard these words of wisdom before. Sadly, and those words of wisdom are, you don't have a backup until it's been restored. And sadly, many production systems remain exposed, not even leveraging this most basic component of HADR, much less restoring the backup to test to validate it. While using Twitter to invite folks to my session, a guy named SQL Lensman brought this cleverness to my attention, which I thought was very interesting, those of you who may know a little bit of physics. And this speaks directly to Kimberly's words of wisdom. The condition of any backup is unknown until a restore is attempted. And that's true. How many people think they have good backups but haven't tested them? Happens again and again and again. So if you're one of those folks that are taking backups but not restoring them and testing them, please reconsider your strategy. And that brings us to my friend, former PFE Ward Pond's 12th law. In pursuit of your 5 nines, don't practice in front of the CIO. The time to practice your HADR strategies is not when you have an emergency. The time to practice them is on a regular basis. You need to be able to roll out of bed at 2 or 3 a.m. and implement these flawlessly. All right? Be rehearsed and be ready to rock it. All right. So from that, let's dive into, again, a high-level overview of failover cluster topology and why availability groups may be superior for some solutions. So this is a classic Windows Server failover cluster. Historically, a very common, often essential feature, especially in the old days before availability groups, for HADR strategy. So we start with our clients. We have a public network. We have our clustered nodes, 1, 2, or more. And we have a private network to communicate between the private nodes. And where is the storage infrastructure? Well, we have redundant switches. We have inter-switch communication. We have storage, typically on a SAN. We have fiber between the clustered nodes and the switches. We have redundant fiber and more redundant fiber. And note that the SAN in many of these architectures is a single point of failure. And there are, of course, ways to architect around that, but that adds complexity, and with complexity comes expense. So let's take a peek at a basically equivalent AG topology. So we have the first 4 components that are exactly the same: clients, public network, the nodes, and the private network. Where's the storage infrastructure? There it is, local to each node. Now, believe me, SANs have their advantages, and they're essential to many enterprise and HADR strategies. But in many cases, especially in the context of SQL Server, they're not necessary. And availability groups can be far more affordable to set up and every bit as robust in terms of HADR or more. There's much less infrastructure to manage, and it's therefore less expensive. And note that a common upgrade strategy from earlier versions of SQL is to move from a SAN-attached legacy server to brand new servers within Server Flash. And as we'll see in a bit, whether your storage is in server or on a SAN, you must have a fast storage subsystem to keep up with the new performance enhancements and always-on AGs. Okay, here's a prototypical architecture of availability groups with local non-shared storage. So we have a primary server, and in this case, then we have an AG using sync log synchronization in the same data center. And we may have another AG, another server hosting the availability group in a geographically dispersed data center, and it's close enough that we can still get by with synchronous log synchronization. And if we really want to be thorough, we have another geographically distributed node, and this one's far away. And we're using async replication. When you set up your nodes, whether it's clustering or availability groups, please be sure to apply the hotfixes and updates you can find here. Now, we're diving, okay, that was my overview. I've given you a little bit of, KD graciously told you a little bit about me. We have talked about a little bit about HADR and how important it is, and not to underestimate the complexities, especially in terms of people and processes. We've talked about the absolutely fundamental importance of a backup strategy, as well as testing your strategy, including regularly validating your backups. We have compared and contrasted a clustered HADR strategy with a prototypical architecture of availability groups strategy. And now, what you've all been waiting for, this is the, oh, we got through that in only 15 minutes. Not bad. Now we get to talk about the availability group enhancements. So, again, I'm not going to read everything here, but let's get this show on the road. We have a long list of new features and functionality to get through. This and everything that follows reflect the incredible effort the SQL Server Program Group has invested in the product for 2016. These outcomes are very impressive, and as I've suggested, I am most excited about the incredible perf enhancements, and I've saved the best for last. So let's dive in. Okay, there are fewer dependencies here. SQL Server 2016 has a dependency, if you want to call it that, on 64-bit. There is no 32-bit SQL Server 2016 edition. And folks, that's a good thing. And check this out. Finally, no dependency on the .NET 3.5 framework. So many of us have set up servers, and we had to go back to the server manager and updated and do a separate update of .NET 3.5 to our server before we even started the SQL Server install. No longer necessary. And this is the big one, no dependency on Enterprise Edition. SQL Server Standard Edition supports availability groups. Enterprise Edition is no longer required, and editions which support availability groups in 2016 include Enterprise, Developer, just as before, but also Standard Edition. And I have a separate slide on that. In addition, we have something called domain-independent availability groups. No dependency on Active Directory. That's been a long time in the making, and we have it now in 2016. So let's talk a little bit about Standard Edition support. Many of you know that database mirroring has been marked for deprecation, and but we didn't have a replacement announced until recently. So this is pretty welcome news. And so the implementation in Standard Edition is relatively straightforward. Basically, the functionality is limited. In fact, it's basically an updated database mirroring, limited to 2 nodes, just like DBM. The secondary replicate cannot be rendered readable, just like DBM, and each database must be in its own availability group. You can't group multiple databases in a single availability group. Again, much like DBM. And Brent Ozar has a really great walkthrough in this blog post that I've cited here, if you want to know more about Standard Edition support. I'm not going to go into great detail here, but the takeaway here is, after a great deal of collaboration between the SQL Server and Windows program groups, there's a lot of work to provide compatibility not only with all nodes in a single domain, which is what was required before 2016, but now you can support availability groups in multiple names with full trust. They can be supported in multiple domains without trust. And the nodes, one or more nodes, don't even have to be in a domain at all. They can be members of a work group or different work groups. Pretty exciting and interesting stuff. Lends itself to a great deal of flexibility in those enterprise environments out there. More info and a very detailed walkthrough is available at this blog from Kevin Farley of the SQL Server Program Group. Next big group of enhancements for availability groups, security. Encrypted databases are now supported, and actually this should be amended to say encrypted databases can now be supported by creating them in the wizard. And authentication is required when adding databases to the AT, so have your credentials ready. Group managed service account. For those of you managing large enterprises, you're familiar perhaps with managed service accounts for a variety of implementations such as network load balancers, SharePoint farms, etc. But availability groups prior to 2016, you had to log into each server manually to update certain aspects, certain security aspects. Now you can upgrade availability groups from one point. You don't have to go to multiple servers. You don't have to go to each node. Thank you, Windows and Microsoft, for your cooperation there. And we have a more secure endpoint encryption. The differences between AES, which was the current implementation, security implementation, versus RC4, which is the former implementation, can be found here. Pretty interesting article and pretty consumable even for those of us who may not be security geeks. Again, overall, 3 very nice improvements in terms of security for AGs in 2016. Okay, failover enhancements. Again, long requested support for additional failover partners. Now we can have up to a total of 3 replicas, including the primary and 2 secondaries. That can be configured to fail over automatically. Pretty nice. And we have database level failover options, much more granularity in how we control our failover. It isn't just at the server level anymore. And again, another example in which the program group has really stepped up. A distributed transaction coordinator is now supported. And why is that important? You have link servers, more procedure calls, distributed transactions, etc. Well, those all require DTC, and now DTC is supported in availability groups. Thank you again, Microsoft. Now, this is an interesting one, direct seeding. Many of you probably haven't heard of this yet, even if you work with availability groups all the time. Traditionally, backup and restore was required to configure AGs, explicit backup and restore, or doing something equivalent through the UI. And you also had to use backup and restore to add new secondaries in SQL Server in 2014. But now we have direct seeding. And this just basically allows you to create an availability group through the wizard. No explicit backup and restore. SQL Server just streams a backup across the wire. Now, the problem I have discovered with direct seeding is that it's a little bit slow. It's single-threaded. Some of us may be familiar with some of the knobs to tune backups, multiple devices, max transfer size, enhanced buffer count. And those just aren't available with the direct seeding. So you have a big honking terabyte, multiple terabyte database. It's going to take a long time to establish this availability group if you use direct seeding. So hopefully they'll respond favorably to the Connect item. And I invite you to check this out and go vote for it. Thank you. Distributed AGs. Some of you who work with availability groups or other kinds of HA may be familiar with Alan Hurt. He's a big fan of these. He works with in a lot of big complex situations. Many of us, for a lot of our implementations, will never ever implement these. But for those of us who have multiple data centers, we now have the possibility, the option, to create what is basically an availability group of availability groups. And the scenario the architecture looks something like this. We have AGs, discrete AGs, availability group 1, AG2, in separate data centers. You can join those under the auspices of one availability group. The flexibility of this config, this example, check it out, it's very flexible. We have 3 replicas in the main data center, and we have only 2 replicas in the secondary data center, presumably for DR. Now, the flexibility here means that you don't have to exactly emulate and mirror the physical architecture, so there are some money savings there. And this is more efficient for data transmission. Only if if the servers in AG2 weren't in a, quote, distributed AG, each one of those would have to have a separate stream of data across the wire. And this way it's more efficient. We only have to have one copy of the data streamed to the primary AG in the second availability group. Oh, by the way, the second, a byproduct of this implementation of distributed AGs is that the primary in the second AG becomes read-only. Very interesting. So basically, just like in a standard AG, only one database can be written to. Others can be read-only, but even the primary in a, quote, distributed AG can be written to. The secondary AG's primary can't be written to. Yes, I know, that may sound a little complicated, talking about multiple AGs, multiple primaries, etc. You want to know more? There is a little article you can check out for yourself. And Alan Hurt has threatened to write another post on this. Let's hope it comes through soon. I'll be keeping my eyes open for it. All right. This is very exciting and very unknown. As far as I know, this spec is the only time it's been publicly announced. By default, in 2012 and 2014, all log transport traffic was compressed for both sync and async. There were trace flags to change that behavior, but the defaults were compressed for sync and async. And compression consumes CPU. So let's suppose you have well, I'll get to that in a second. In 2016, the default, and again, this is very little known. In 2016, the default is to not compress that log traffic. By default, no CPU cycles are invested in compressing that log traffic. However, for async mode, and this is for servers that are presumably located some reasonable distance away, geo-distributed perhaps in separate data centers, the log traffic is compressed. And so you see the optimizations here were chosen, in my opinion wisely, that are uncompressed in sync mode to conserve CPU, the compressed in async mode to maximize network performance across the wire. And here's the trace flags. If you want to modify that behavior, whether in 2014 or 2016, here they are. And I'll be doing some experimentation with it, my team and I, and we will be writing a white paper, hopefully before the end of the year, with regard to not only testing of these options, but the other options as well. Readable secondaries, another big area, massive enhancements, multiple enhancements. So what's a readable secondary? It is a secondary replica configured to accept read-only queries, and also you can point backups to it. This is often used for reporting, analytics, backups, etc. And the goal here is to take the load off of the primary server, which is presumably, well, not presumably, the primary server is servicing applications from production, and they may be performance sensitive, and they may be OLTP type workload, and you don't want to intermingle for performance, reporting type, analytics, or backup workloads. Completely different kind of requests are required to support analytics and reporting and backups. And so by offloading the work from the primary server, you can serve resources. So the enhancements are, if you have multiple read-only secondaries, now you can round robin between them automatically by simply configuration change in the using Transact SQL or PowerShell. Also, there's enhanced Azure support and clustered column store support. Clustered column store was not supported in readable secondaries in 2014. In 2016, they're fully supported. Something to be aware of. I mentioned the custom column store support. That had to do with the way readable secondaries are implemented and their impact on the primary. You also, just in general, independent of cluster column store, you need to be aware of the impact on the primary by readable secondaries for queries directed against it. There are also licensing implications. When you flip that readable bit and say, yes, I want to read from the secondary, you've got to pay for that licensing on that server. And those of you who have ever been involved in a licensing exercise, you may know just how expensive SQL Server licensing is. The cost of the hardware pales in comparison to SQL Server licenses. And beware the performance on Flash. I mentioned that there are some performance implications. If you, the reason that we have readable secondaries in the first place is to offload work from the primary. Well, if you're on Flash instead of conventional storage, you may very well be able to accommodate all the workload that you need on the primary server, because I/O typically isn't a bottleneck when Flash is involved. It can be, but typically I/O historically has been the bottleneck, and one of the whole points of Flash is to move the bottleneck, the performance bottleneck, to the CPU where it belongs, and that allows you to better leverage your licensing enhancements or your licensing considerations. Okay, I have a little bit here about readable secondary load balancing. By default, no connections are allowed to the secondary. This is just a little bit of a deep dive into round robin. In 2016, we actually choose the servers we actually choose which servers are readable, but how those servers are accessed, the order in which they're accessed, and still at the same time make some readable secondaries not accessible if we choose to for readable secondaries within a primary data center, for example, and we have a readable secondary and those readable secondaries are available on a day-to-day basis for readable queries that report, etc. But we might also have a readable secondary in a data center far away. But we don't want that access on a day-to-day basis because it's there only for availability, only for disaster recovery, and we want to configure it for read-only, but only in the event of a failover. The takeaway here from the enhancements to round-robin load balancing are that we can choose which servers participate, which read-only servers, which read-only replicas participate in the round-robin load balancing, still preserving servers in a remote data center only for emergencies to minimize traffic and response time across the wire. For those of you who implement such a feature, you may very well appreciate it. Azure support. Introduced in 2014, enhanced in 2016. Best practice, if you use Azure for a availability group, almost inevitably you need to use async availability mode. The network performance just isn't there to support sync commit. And more info, and Books Online provides a lot of great info if you're interested in implementing Azure in the cloud. Excuse me, implementing availability groups in the cloud. A moment ago, I mentioned the challenge with clustered column store and read-only secondaries. SQL's 2014 supported clustered column store, but only on passive secondaries. And non-updated non-updatable, non-cluster column store was fully supported, but cluster column store, which was one of the most exciting features to come out of 2014, was not supported on readable secondaries. It was tragic. And by the way, cluster column store in 2014, let me just digress for a second. My colleague and I at the Data Propulsion Lab, Brian Walters, still think that cluster column store was the single best feature to come out of SQL 2014. And not just because it's writable, but because of the largely underappreciated enhancements to the optimizer. Columnstore is the default index of choice for data warehouse and reporting type workloads. It's a game changer for many apps. So if you're not using Columnstore for your DWs, your analytics, and other reporting workloads, consider doing so. Again, a game changer for many apps. But I digress. Thank you for indulging that digression. I mentioned the cluster column store was supported in 2014, but not on passive readable secondaries. And I'm not going to go into detail here with regard to why, but Paul Randall did a really great job of describing, and this is something I bet many of you aren't aware of. So whether you're using cluster column store or not on readable secondaries, if you're using availability groups at all in any context with readable secondaries, you need to read this article. Yeah, I've got a couple of links here that briefly describe it, and I invite you to take a peek at it. And the bottom line is, it's all fixed in 2016. 2016, again, fully supports cluster column store on readable secondaries. Okay, licensing performance. This is pretty interesting. I mentioned licensing a second ago in the context of readable secondaries. Licensing is complex. And I'm going to leave that to the experts. It's also expensive. It can cost up to $500,000. This is no kidding, folks. On a 2-socket commodity server, licensing for Enterprise Edition can cost as much as $500,000. Almost always over $250,000. It's incredible. Yeah, as I say here, Enterprise licenses for a modern commodity 2-socket server, $200,000 to $600,000. Period. Some of you, if you're in education maybe, or have a million licenses, may have some special discounts on a per socket basis or per core basis. But in general, you buy a pair of SQL servers or a SQL server, you're going to, AGs or not, you're going to pay $250,000 to $500,000 for the licensing. One of the exciting things that we've demonstrated in the Data Propulsion Lab where I work is we've demonstrated many scenarios in which in-server flash supports workloads that used to have to be offloaded to readable secondaries. And the takeaway there is, if you are using readable secondaries now or are planning to, consider using in-server flash and testing your potential workloads against them, and including the backups and/or including the reporting queries. And you may very well find out you don't have to flip the readable bit on the secondary server, on the secondary replica, and therefore save yourself the licensing costs and potentially huge savings that you can say, and your people may not be aware of this possibility. So consider it. If you're upgrading to SQL Server 2016, and you're very likely doing so on new servers, and if you're considering read-only secondaries because of the offloading the work, consider not doing so and saving yourselves a lot of money. Be a hero at your org. Okay. I have a little digression here into I/O performance. And I think we're good on time, so I'm going to go for it. Historically, people request performance or request capacity, and they're just given, for example, a terabyte of storage. But the way to really ask for storage is to ask for your capacity in terms of IOPS and in terms of the latency that's required to support your application. Or if you're doing asking for storage for a data warehouse, instead of IOPS, you ask for the throughput that can get at an arbitrary latency. arbitrarily low latency. And why is this important? Because minimizing and optimizing I/O is a best practice. So when you request storage, I came up with this, and this is something I evangelized to my customers starting years ago as a consultant, and I brought it with me to SQL Cat. And but these millisecond latencies seem quaint now in these days of Flash and microsecond latencies. Oh, by the way, log files are special. We've probably heard the best practice of commingling log files with data files, and the reason is very important. Not going to digress into the details, but basically, if you commingle log files with, you're subjecting that log file. The log file has hard limits in terms of outstanding I/O, and if you do anything to compromise its performance and intermingling it with other workloads, definitely will compromise performance. You're slowing down your application, almost guarantee it, and by an order of magnitude or more. So, how do you optimize I/O? What if I told you the only good I/O is the one for which you do not ask? I love these memes here, and I did happen to make this up and put it in front of Morpheus, but I didn't come up with a concept. One of the co-founders of Intel actually said something similar many years ago. The best I/O is the one you don't have to do. So I didn't make up. The best I/O is the one you don't have to do. And what's my point here? My point here is by maximizing your I/O, minimizing your I/O, especially minimizing writes, you're minimizing work that has to be dealt with by your availability groups, minimizing data that may have to be encrypted and compressed, and minimizing traffic across the wire. And here is a great best practice in order to do that. Even in the context of availability groups or any SQL Server database, consider implementing all of your index maintenance by leveraging stored in TempDB. Let your performant, presumably your TempDB is performant, presumably you've indulged in best practices and optimized your TempDB for performance, and doing so is performant, again, for any SQL Server implementation, but especially for databases involved in availability groups. And you want to test some of the options that might be available, and especially if you want to look at some guidance regarding availability groups and reindexing, check out this post from my friend Nick Kane, Sir SQL on Twitter. Okay. We've talked about many areas of many broad areas of availability group enhancements. I've dived into a few details, and I've said that I would save the best for last. At least one, in my opinion, is the best. And now we're talking about the really incredible performance improvements delivered by SQL Server 2016 AGs. So all the experiments which follow were performed with a hardware configuration very similar to the following: a single injector to generate the workload, a single two-socket commodity server to serve as the primary, and one or two secondary replicas, and in synchronous commit mode. In some experiments, a single PCIe card was used. In other experiments, we used two. Okay, so before I go on, I've got to talk about the bottleneck that was in 2012 and 2014. That was just such a heartbreak for many of us. Always-on AG's functionality is based in the code with database mirroring. They are originated from the same code base. And the performance bottleneck I'm going to describe has its roots in code that was over a decade old. It had two built-in performance bottlenecks: the log transport and the redo thread. And let's cut to the chase by looking at a diagram. Here's a diagram: primary AG, primary replica, secondary replica. Here is the log transport. It's simply the process that encrypts and compresses the log traffic to the secondary replica. Another bottleneck, separate, was the redo thread. It has been enhanced in 2016 as well. And a redo, think about this as a continuous restore thread, applying changes made on the primary replica to the secondary replica. For our purposes, we're going to focus on the improvements in log transport, and they're truly impressive. So let's talk about them. This is you saw a little bit of this slide way back early in my introduction. Look at CPU, enhanced by over a factor of 4. And by this bottleneck being liberated, we liberate the CPU to do more work. Let me start over a little bit. Let's look what happens when we flip the SQL Server 2016 faster bit. I need to emphasize that the very same hardware was used for both experiments. The only difference in the protocol was the version of SQL. This experiment demonstrates one of the most exciting outcomes that from the work that the SQL Server program group did this year. SQL Server 2016 unleashes the product to do more of what it's supposed to do. It leverages more processor, as we see here, by over a factor of 4 to drive more workload. And more workload, how much more workload? In our experiments, over a factor of 5. And it did that because by fixing bottlenecks in that legacy database mirroring code and that the availability groups in 2012 and 2014 inherited, it opened up a bottleneck. And in our experiments, that bottleneck was liberated to the tune of 5 times more work going across the wire. Folks, check this out. This is 1/2 of a gigabyte a second going across the wire. Just amazing. And again, the very same hardware, only difference is that we upgraded to SQL Server 2016. And you can see that the secondaries receive this workload and they apply it to their secondaries almost as quickly. Pretty exciting stuff. Again, as I said earlier, you do not have to be a rocket scientist. You don't have to know all the details about the workload here to see something very profound that's going on. And this allows us not only to leverage our processors better, but look at our storage infrastructure. We were able to get 3 times double the disk throughput, and we were able to do this on flash on both experiments at under a millisecond of latency. Imagine that. This is an OLTP random workload generating over 1/2 of a gigabyte of work per second, and we're servicing that workload at less than a millisecond of latency. Just phenomenal. So if you guys aren't excited about SQL Server 2016 availability groups on flash, you really, really ought to be. Here's another view. This is an experiment we did more recently at the Data Propulsion Lab where I work by my colleagues Brian Walters and Neil McLeod. In this case, only one single PCIe card was used. And using the traditional SQL Server engine, this is just a conventional TPCC-like workload, not Hackathon. SQL Server delivered AG throughput here of about 50 megabytes per second. And this is basically all we can expect in SQL Server 2012 and 2014 AGs. This is traffic across the wire. Now check this out. And again, no Hackathon implementation, just classic Transact SQL. We're generating, in this case, 1/4 gigabyte across the wire. Nothing exotic here at all. Again, same hardware, just upgraded versions of SQL Server. Just amazing. 5 times the throughput, 5 times the work. And this slide, folks, if you get nothing out from this presentation, besides maybe investing in your HADR strategy, which is the most fundamental thing, my takeaway would be these kinds of performance enhancements that I showed here and on the previous slides. Okay, let's wrap up and talk a little bit about async versus sync. The purpose of this chart is simply to show the impact on a free replica AG, 1 primary, 2 secondaries, of sync versus async. The async throughput is about 77,000 transactions per second, and we, oops, excuse me, oops, Tip of the day, folks, when you go to your customer servers, don't sit at the console and utter the word oops. Okay, back to the presentation. The async workload is 77K transactions per second. When we flip to the synchronous bit, there's a little bit of overhead there. We have a delta of about 10%, 10.7%. And our experiments confirm this. 10, 11% is the performance impact of async versus sync. And that's important. The point here that I think is important to make is when we have a sync workload, we have a far greater likelihood of preserving our data, not losing any data in the event of a failover. With an async workload, not only is there no guarantee, I can practically guarantee you there will be data loss on failover of an async AG. So at the cost of only 10% of your throughput, you have a far greater likelihood that your data will be preserved. I think it's a good bet for those of us whose data is important to our enterprise. A synchronous availability group is a good bet. Here's another one. I like this. This demonstrates the consistency of availability groups. I like it. So we did 3 tests, 3 on 2014, 3 on 2016. You notice that CPU utilization was only 11%. 11%, because even though the SQL Server was cranking as far as it could, it was bottlenecked. That log transport bottleneck I described bottlenecks the entire system. And in this case, our SQL Server could only crank away at 11% CPU. What a tragic waste of resources. Whereas in 2016, in this particular experiment, we had over 3 times the CPU. And not only CPU utilization on the left, we see on the right, we had over twice the transactions. Pretty good. Again, I emphasize, the very same hardware is being used for these tests. In our case, 2U commodity boxes with in-server flash. The only difference is the version of SQL Server. Simply upgrading makes your availability groups run faster. You get all this extra perf simply by upgrading to the latest and greatest version of SQL Server. And I remind you, you must have a storage subsystem to support this kind of throughput. Most of you know that I work for a company that sells flash. I'm not here to sell you flash. I'm here to help you make your applications go faster. And that requires SQL Server 2016 using flash. All right, and there's the trend, by the way, demonstrating consistency. And with that, our performance segment is over. If you have a few minutes, check out this 11-minute YouTube video from Kevin Farley. And this was part of the data-driven launch of SQL Server 2016. Pretty neat stuff, where I've repeated them a bunch of times, how proud I am of the SQL Server group for all the work they have done in 2016. Well, Kevin is equally proud. He's part of that group, and he has a right to be proud. And so check out this video. A whole lot of references here. SQL Server, SQL HA, Alan Hurt. They don't call him SQL HA for nothing. He's the master. Mission Critical SQL Server, my friend, MTC Director Ross Laforte and I did a webinar last March. The results are still relevant. I invite you to check it out. And it doesn't just talk about availability groups. It talks about a spectrum of enhancements across SQL Server 2016. My friends and I at the Data Propulsion Lab post as often as we can regarding performance enhancements, and many of them involve SQL Server 2016 and especially AGs. Books online is indispensable for learning about AGs. Here's a white paper that I helped review, and I was a member of SQL Cat. And by the way, I am currently working on a reference architecture, which we hope to have published within the next 2 or 3 or 4 weeks. And as I mentioned earlier, we have a much broader and deeper white paper we hope to publish by the end of the year. So keep your eyes open for those. You want training? No better resources in the world than SQL Skills and SQL HA. And acknowledgements, thank you, SanDisk and my colleagues here. And thank you, Microsoft, and my colleagues listed. And for here are some third-party folks who contributed to this presentation and the collateral that I shared with you. And let me leave you with this. For any storage investment these are friends of mine. Any storage investment you guys make today, that your organizations make today, you're going to have to live with for the next 3 to 5 years more. Seriously consider the quality of the storage, the performance of the storage that you're investing in today. Okay, and I emphasize, lastly, fully leveraging the advantages of SQL Server 2016, especially if AGs are involved, requires Flash. And we have a call to action here. AGs, as I hope I have documented to you thoroughly, have been significantly improved across a wide set of areas. Simply upgrading from earlier versions of SQL Server will provide significant functional and performance benefits if you have the infrastructure capable of taking advantage of it. And start now. You can do that right here by clicking that link. And in the meantime, folks, validate those backups if you're not doing it. Okay, that's it. KD and audience members, thank you very, very much for listening and attending. If you have any questions, I'm open to taking questions. I'll stay here for as long as you guys need me to. But again, feel free to ping me directly.